Jai Hind, myself Dr. Ajay Pratap Singh, Associate Professor in Ajay Kumar College, Ghaziabad, Department of Mechanical Engineering, and I teach here today the topic, the subject basically theory of machine, and in this I will cover the inversion of mechanism then 4 bar chain, then inversion of single slider and the inversion of double slider crank mechanism. So what is I'll discuss here basically what is the criteria for selection of or conversion of inversion of mechanism, what is the limitations, what is the benefit. So I'll discuss here. In last lecture I have discussed the degree of freedoms, Kurzbach criteria for the planar mechanism, that the value formula used F equal to 3 into L minus 1 minus 2J in minus H. So I have discussed in last lecture. So the Kurzbach criteria I have discussed F equal to 3 into L minus 1 minus 2J minus H, where you can where that is the L is the number of link, uh, J is the number of joint in terms of binary joint, as H is the higher pair. So all you are after using this formula, you find out the degree of freedom, how much degree of freedom in the any mechanism, right? So come to this topic for the after the discussion of this the inversion of the degree of freedom and for the planar mechanism. So the come to the topic of the inversion of mechanism, and it's an important topic because if you design any mechanism to transfer the motion for one form to another form, like a rotary to linear motion or linear to rotary motion, and for the with the attachment, so we find out the quick return mechanism is the part. Suppose ki if you move in forward direction, the time is more time taken, but if you return in the back in the quick motion, so you can say that the quick return mechanism. So we'll decide according to the application based on the basis of the inversion. So uh, inversion of mechanism, we can say one of the link is fixed in the kinematic chain, it is called the mechanism, right? So we can obtain any mechanism as the number of links in a kinematic chain by fixing in turn different links in a kinematic chain. So the method of obtaining the different mechanism by fixing different links in a kinematic chain is known as inversion of mechanism. Suppose you can see here in the figure A, B and C and D. There are 4 figures, right? And in this figure, we have find out that is the 4 linkage. Link number 1, link number 2, A to B is the link number 1, A to C is the link number 2, C to D is the link number 3, and D to B, that is the link number 4. So total 4 link is here. So I'll mention here the A, B, C, D in all the figure. A, B, C and D. A, B, C and D, A, B, C and D, right? So you can see here in the each figure, in the figure A, figure B and figure C, the different link with the link with the fix. In the figure number A, that is link number 1 is the fix. In the figure number 2, the link shortest link is the fix. Then figure number 3, we fix the that is the link number 3, and uh, in case of the figure V, we fix the link number 4. So we fix up the different links in a kinematic chain, and we can say that's the different type of the motion will be transfer, or you can obtain the output in a different type of the motion for fixing the different linkage. So uh, in the 4 bar chain, if you say the 4 bar chain, that the Grossov's law is very important. It came in the picture, and Grossov's law is the 4 bar for development of the 4 bar, or we can draw the 4 bar. That Grossov's law mechanism is very important. Basically, for draw the 4 bar mechanism, what the Grossov's law says that the sum of the shortest and longest link of the links length should not be greater than the summation of other 2 links if there is to be continuous relative motion between the 2 links. So these are the basic rules. So you can see here that the figure number in the 4 bar chain, that A, there are 4 linkages in there, one link is the fixed. So the case of the shortest link and longest link, the summation of shortest and longest link should not be greater than, you can say, other remaining summation of the two links. So in the 4-bar chain, you can say that the link in the particular, the shortest link will make a complete revolution. You can see here in case of this, that the shortest link number 4, that is the AD, is will a complete revolution to relative the three links, and it is satisfied the Grossep's law, and such link the whole, the known as the crank or the driver. In here you can see that the link number AD, link number AB is the fixed. So that the link number AD, the shortest link, is known as the crank, and the link number BC is the link 2, where the link number BC, you can see that, you can see here the BC, this one, link number 2. So BC, which makes a partial rotation or oscillation, either lever or rocket or the follower. So you can see if link number A, link number 4 is rotated, that oscillate about this line, right? BC will be oscillated at that point. So the oscillating point is known as, you can say, the lever or rocker or the follower, you can say. And the link basically 3, you can see in the DC. So which component that which connect the crank and the lever is called the connecting rod or the coupler. So he'll connect basically the crank and you can say the lever to connect with this. So that these links DC is known as the connecting rod or the coupler, and the fixed link AB is the fixed. So in the frame, so it is known as a frame. So these are the mechanism. So when the crank link 4 is driver, the mechanism is transforming the rotary motion into the oscillatory motion. So we can see here, you can see here, if the link number 1, link number 4 is rotate at point A, so we find out that is the rotary motion is convert to the oscillatory motions, right? So if shortest link, that the crank is rotating about the axis, then the link BC will be oscillate, and this we can say that is the driver. In the link number 4, the mechanism is transforming the rotary motion in terms of oscillating motion. Another application, the 4-bar chain, you can see that the 4-bar you can fix up the one by one. So the first one, you can say that the link number 1 is fixed, that the crank and lever mechanism is there, then double crank mechanism, then the crank and lever mechanism, you can say that is the oscillatory motion is known as, right? If the double crank mechanism, the complete rotation of the crank and follower, you can say. If the couple of the wheel of the locomotive wheels, the double crank mechanism, and the pantograph is the used for the straight line mechanism, so that is double lever mechanism. So according to name of this, you can find out which type of the motion there. So crank and lever mechanism will be oscillatory motions, right? Double crank mechanism means the complete rotation of the crank and the follower. Coupled wheels of the locomotive, that is the same, the crank, the connecting rod is a crank in the parallel direction, and that two crank is there. Double crank means double crank is required, right? The pantograph mechanism, that is a lever of the mechanism, double lever mechanism, and used in the straight, you can say that it draw the straight line mechanism. So beam engine, or we can say the crank and lever mechanism. So you can see here a part of mechanism. In this case, you can see the 4-bar mechanism. You can see that the 4-bar mechanism we draw. So you can find out in the beam engine, or we can say the crank and lever mechanism, a part of mechanism of a beam engine is also known as the crank and lever mechanism, and which consists of the 4 link in shown in figure this. So you can find out the link number, all the link 4, and in this mechanism, when the crank rotate about the fixed center A, the lever oscillate about the fixed center D, right? So you can see that is this is the crank position. So crank 1 is rotating. You can see here that is the crank 1 is rotating. So lever D is oscillating at point D. Here you can see that is the oscillating at that point, right? So and the end, you can see that point E, the lever CDE. You can see that CD and E is connected to a piston rod which reciprocate due to the rotation of the crank. In other words, we can say that is the purpose of this mechanism is convert rotary motion into the reciprocatory motion. So here you can see that the crank 1 is the rotated, right, and this the transformation is the mechanism, like here that is the in terms of reciprocatory motion. So you can see here rotary motion is converted to the reciprocatory motion. Second, we can say that the double rod of locomotive engine, so double crank mechanism you can say, and this mechanism of the coupling rod of the locomotive you can say also known as double crank mechanism, and we can say which consists of the 4 linkage. In this figure you can see that is link 1, 2, 3, 4. So total 4 link is there, and link of AD, these link 2 link, that AD and CV link is the equal link, equal length, and act as the crank and are connected to the respective wheels. So the link CD, so this link CD, that is the link number 3, acts as the coupling rod, and the link AB is the fixed as a frame. So to maintain the constant center distance between them, so the mechanism is meant that for the transmitting the rotary motion of the one wheel to the another wheel. You can see here in the figure, that is one is the back end, that is the frame is there, 2 crank, right, and that is the connecting rod we can say, or is the coupler connected, that is these are the coupler basically that rotate. So these are the mechanism is mean the transmitting the rotary motion from one wheel to the another wheel. Third one is that is watt indicators, you can say they are double lever mechanism. That watt indicators mechanism is also known as the watt straight line mechanism or double lever mechanism. It is used for to draw the straight line mechanism basically, and we can see here that the figure A, B, C, D, E. So you can see here that's the point here, that these are the mechanism basically you can say, and it move like this. This position from this point A, the extended point E. So the line will be moving in the straight line. So which consists of 4 link in this case, and the 4 link are like you can see that is the A is the fixed link, we can say that is point in here, you can find out A is the fixed link, then the 4 AC other link is the AC is the other link, right, then CE is other link, and the BFD is the another link. So total 4 link in this case, and it be noted that the BF and FD, we can say this link BF and FD from one link, because these two parts have no relative motion between them, and then the link CE and we can say the BFD act as a lever. So you can see here that BFD, the link BFD acts as a lever you can use, and we can say the link CE basically C and E, this link link CE is used, and that BFD act as the double lever basically, you can say there are 2 lever are used, so that is called the double lever, and this the displacement of the BFD directly proportional to the pressure of gas of the steam which acts on the indicator plunger. So on a small displacement of this the mechanism, so you can say that the tracing point E, if the small displacement from this to this, right, so the tracing element point E, we can say the end of the link C trace the out of the approximately, you can say that the straight line. So if you movement like this, the movement like this or this, so this straight line is follow point T is follow like a straight line, right? So Watt's indicator mechanism are used to draw or create the straight line mechanism. You can see here in this, that's the find out the straight line, right? In this figure you can see that's the movement. So he can fix here, and that move like this. So he generate the straight line. Now in the 4-bar chain, that is the one important is a single slider crank mechanism. The piston, crank, piston, and cylinder. Basically, you can say so. Single slider crank chain is a modification of basically you can say is the 4-bar mechanism, because in there get also the 4-bar. But in consist of this, we can say one is a sliding pair and 3 the turning pair. That's why called the sliding crank mechanism. and it is foundly you can usually found in the reciprocating steam engine. And this type of basically use of this type of the single threaded mechanism purpose is that convert the basically rotary motion into the reciprocatory motion, or vice versa. These are you can see here in this figure, that is the slider crank mechanism, that is the crank, here the connecting rod, these are piston cylinder. You can see here the animation in this figure, you can find out that this red one, small red one, is called the crank, right? This is the connecting rod, blue color. Then a small slider is here, that is called the piston, and this the frame is the fixed here, that is the cylinder. So that's the slider crank mechanism, and one we can see here that all the here and connected to this one. Then turning pair, three turning pair is there, three turning pair. One is the sliding pair. So sliding pair is piston. The movement between the piston and cylinder is called the sliding pair. But you can see here that a fixed one, so connected. This one connected and this one connected. So this is called, that's the turning pair. Now, inversion of slider crank mechanism again is the very important. If you fix up the four linkage in the slider crank mechanism to set up inversion of obtain when the link 1 is fixed and link 2, 3 are made the crank and respective. So in that case, there are 4 inversion is possible in the slider crank mechanism, and we can see that if the link number 1 is fixed, so link number 1 is fixed, so it means these are the application for reciprocating engine and reciprocating compressor. And if you can see if we transfer the motion from rotary motion to this reciprocatory motion, so you can use this type of the first inversion. Come to the second inversion, you can see here that the second inversion, that the second link will be fixed, right? So you can see here that the second link will fix, and the second link will slider crank is fixed. So in that case, basically the slider crank mechanism, link 2 will fix instead of the link 1, and link 3 along with the slider, it's you can say end of the B become as a crank. So it makes the link 1 rotate about 0.0. Link 1 rotate about the 0.0, right? With the slider which also reciprocates. So these type of the applications are used in the quick return mechanism or the rotary engine, basically you can say. So you can see here the application of quick return mechanism. You can see here that the slider crank mechanism is, you can see here that in the 4-bar mechanism, that the second inversion. So these are the second inversion, right? These are point B, A. So your link 2 is the fixed. What is the extra in this case? One link is extended. Link 1 is, just I'll show in the different color, so it's helpful. So you can see here that link OB is extended at point come to the C, and one additional link will added, that the link number 5 is C to E, that the link 5 is extended, one point is added, and link 5 are used one here, that the one tool with slide like this, right? So in this mechanism, for the without quick return mechanism, you can say in this mechanism used to workshop of the cutting metals, and the forward stroke a little longer and cut the metal, whereas we can say the return stroke is ideal to take the shorter period of time. So slider 4 in a circle about A, we can see the link, you can see the figure, the point C, point of the link A, 1 is extended and backward where the link 5 is pivoted. So at another end of the link 5, you can say the other end link of the point 5 is pivoted, or the tool, you can say that the forward stroke of which cut the metal. So we have fixed up the tool here at the point, right, for the end of this link 5. So one extra tool is added, and this axis of motion of slider tool passes through the point O. right? So it rotates like this. If he extended like this or like this, it's rotating. So in that case, what will be happen? The initially we can say the axis of the motion of the slider passes through point O and it is perpendicular to OA, the fixed link, and the crank 3 rotate in the counterclockwise direction. Suppose so initially we can see here just you can see here that initially let the crank slider, you can see in the 4.4 that it will be the B dash, right? So you can see here that the it rotates here, that the B dash, and so that the CB at the C dash cutting tool 6 will be extended extreme left position with the movement of the crank, and the slider transfer the path. We can trace that is the B dash, B double dash. So you can see B dash, B double dash, B dash. So we can see here, and other thing where the point C moves through C dash, C double dash, and the cutting tool 6 moves the forward direction. So finally we can say the slider B assume the position of B double dash. So the cutting tool, we can see the extreme right position. So B becomes to the B double dash, right? You can see here B becomes a B double dash. So if B becomes a B double dash, in that case you can see to right line highlighted. So this slider is moved like this and come to this. So in that case, this link will be come to the extended position, go to the extreme right position, right? And the time taken the forward stroke the slider 6 is proportional to the obtuse angle. It makes obtuse angle B dash A, B dash. So you can see here B dash A, these angle, you can see here that is B double dash A, B dash is called obtuse angle at point A, and similarly the slider 4 complete at the rest and circle through B double dash, B triple dash, and B dash, and pass and C passes through C dash double dash, C dash, C triple dash. So there is a backward stroke of the tool, and it will take complete the proportional to the acute angle, and these passes, these are the acute angle, right? So I'll here show the acute angle for the red angle, red color, and obtuse angle is for the green color. So you can see here that it covers the maximum cover in the forward direction, and it will take minimum time to the return stroke. So that's why it's called the you can say that the quick return mechanism, and it's very useful for the you can say in the workshop the cutting of the metals basically. So let us find out the theta is the obtuse angle and beta is the acute angle. So we can see here theta and beta. So time of cutting stroke divided by time of return stroke, that is the theta upon beta. These formula are using for this, right? Again, the inversion of single slider crank chain. So rotary engine, you can say basically you can see here that the 4 rotary engines are using. So it's again the inversion of the slider crank mechanism, and it can be observed in the rotation of the link 3, and the link 1 rotates about 0.0 and the slider is the reciprocated. So in this also implied as a slider crank mechanism, you can reciprocating the one link, and the crank 3 will rotate about A, and the link 1 and about 2. So these are, we can say, rotary engine of the crank 2 fixed and the body of the one rotate, whereas the reciprocating engine, the first inversion called body 1 is the fixed and crank is the rotate. That is the basic difference between the rotary engine and single slider crank mechanism. Again, the third inversion, we can say that the by fixing of the link 3. So we can see that the link number 3 fixing, and the application of this type of this is the oscillating cylinder engine and crank and slaughter lever mechanism. And the fourth inversion, that the 4 we can say link number 4 is fixed. So you can see here that the link number 4 is fixed, right? And that the movement of this also extended the link OA. So at point, so you can see that the oscillating motion in convert to the reciprocating motion, and best example is the hand pump. So these point is a pivoted, is connected to this. So if you move like this, here to here, that if you go to there, right, this upward, so these go to the downward, and if come to the like this, these go to the upward. So that way the oscillating motion is converted to the reciprocating motion. So I hope you are understanding the inversion of mechanism for the slide 4 bar chain and single slide mechanism. Thank you so much.